Hi everyone, welcome back to the session. I hope I am clearly audible to all of you. Perfect. My screen must be also visible. Please confirm if you guys can see my screen. All right, perfect. We'll wait for another 2 minutes and then we are good to get started. All right, so the topic for today is VLANs. So in the session yesterday, we spoke about OSPF multi-area configurations and looked into various important concepts like DR-BDR election. We spoke about how OSPF DR-BDR election works. We spoke about how the OSPF neighborships work. And we wrapped up basically the layer 3 part of the CCNA. Today, we are going to get started with layer 2 part of the CCNA, where we will very firstly, we'll talk about VLANs. Now, what is VLAN? Let's try understanding. VLAN stands for Virtual Local Area Network. What happens basically whenever we connect multiple switches together, they all share the broadcast domain. What does that mean? That simply means if, for example, let's say you have switch 1 connected to 50 devices, and then you have switch 2 connected to 30 devices, and then you have switch 3 connected to, let's say, 100 devices. So in this situation, they all will be sharing the same broadcast domain. Their broadcast domain is going to be 1. What is a broadcast domain? It's the portion of the network in which a broadcast message will be populated. That means if any PC of any of the connected devices will generate a broadcast message, it will be first of all received by all the other devices which are connected to that switch. That means if PC A generates a broadcast message, it will be received by all the 49 devices which are connected to switch 1. Because it's a broadcast, switch 1 will also forward it here. Now switch 2 will give it to everyone, and then will also forward it here, and switch 3 will also give it to everyone. So every time you can imagine, if there is a ARP request generated, all of my 180 devices will receive that message. Why so? Because their broadcast domain is 1. Clear? Now, how do we break this broadcast domain? One way of breaking the broadcast domain is through the layer 3 boundary. If you add a layer 3 device here, which can be a router, and connect all these switches like that, then we can say this will divide the broadcast domain into three parts. Now I can say this will be one broadcast domain, this will be second, and this will be third. Clear, guys? But it is not always possible to use a router, right? And every time I want to break my broadcast domain, I cannot dedicate a router's interface, because routers interface are used for many other responsibilities and purposes, and it will cost me a lot, right, to just divide the broadcast domain. So instead of that, what we do is we use VLANs. How do we use them? Let's understand. Now, still, let's say I have a switch and that switch is connected to 50 devices. These 50 devices contain sales team, HR team, and tech team. Okay. As of now, their broadcast domain will be one, but I can divide that broadcast domain into smaller parts with the help of VLANs. Clear? So by default, all of my devices of any given switch will be a part of VLAN number 1, which is basically the default VLAN. But what I can do is I can create some more VLANs and I can make my devices participate in. For sales, I might create a VLAN number 10. For HR, I might create a VLAN number 20. For tech, I might create a VLAN number 30. So by creating these VLANs, what I did is I divided the broadcast domain into multiple smaller parts. That's basically the responsibility of VLANs. The question is, how many VLANs can I create, right? So like I told you, by default, all interfaces will participate in which VLAN? VLAN number 1. So we call it default VLAN. Then there is a standard range of VLAN, which goes from 2 to 1001. Then we have got some reserved VLANs. These are reserved for certain technologies. We cannot use them. And this range goes from 1002 to 1005. Then I have some more VLANs, which are called extended VLANs. Which can be again used for dividing the broadcast domain. And the range for extended VLAN goes from 1006 to 4094. Clear, guys? Most of the time, we will be using the VLAN from the standard range to divide the broadcast domain. But in case, let's say you are out of the standard VLANs, then you also have got extended VLAN range, which can be used basically for dividing broadcast domain into multiple parts. So we will create a simple topology and I'll connect multiple devices with my switch. All of them will be participating in the same network. Okay. And then I will put them into different VLANs to see if they can still communicate or not. Let's see how we do that. Yes, guys, like I said, if you have made them participate into different VLANs, their broadcast domain will be now divided like the original broadcast domain, which was earlier quite big, will now be divided into smaller parts. and communication will get restricted within that VLAN. I'm sharing my screen again to explain this part again. So yeah, like we divided the broadcast domain. Earlier, my broadcast domain was 1. So any broadcast message was also received by all the other devices, right? But now when I have divided my broadcast domain into smaller parts, any broadcast message which is generated inside the sales team will only remain inside the sales team. It cannot cross this boundary and get into HR VLAN. Okay. Similarly, broadcast of HR will not get into tech team, even if they all are in the same network. Let's say they all are configured in 192.168.1.0. Still, if I divide their broadcast domain using VLANs and I put them into different VLANs, they'll not be able to speak with each other or send the broadcast messages to each other. Clear? All right. Like I said, we'll create topology looking like this, and let's see how VLANs can be configured. Sharing my other screen. I'll take one switch, the very first switch from the available options, and I will connect multiple devices with it. Assume these two devices are from sales team, these two are from the HR team, and these two from the tech team. Let's connect them all. And then I will put them all into the same network 210.1.0. So I'll go to my PC0 desktop IP and I will configure the IP 210.1.1. Then PC1 desktop IP 210.1.2. 210.1.3. 1.4. 1.6. Now, as of now, they all are participating into the same broadcast domain. So if I make any communication from PC0 to any other PC, let's say ping 192.168.1.2, I will get my replies and all the broadcast messages will also be received by everyone. Let's see. Oh, okay. I'm using the wrong IP. It should be 210.1.2. Yeah, we can see we are getting the replies. Similarly, if I ping 210.1.3, I'm getting my replies. If I ping 1.4, 1.5, 1.6, all of them basically are reachable. Now, like I discussed, I want these two to be treated as sales team, these two to be treated as HR team, and the last two from the tech team. This is sales team, this is HR team, and this is tech team. Now, like I told you, by default, all the interface participate in VLAN number 1. How can we confirm that? If you hover your mouse on your switch, you get the details of all interfaces, and you can see here the VLAN is specified as VLAN 1, right? Then if you go to the CLI of switch, enable show IP interface brief, we can see how many interfaces do we have. We have so many of the interface FA01, 2, 3 up to 24, then gig01, gig02, right? And if you check show VLAN brief, that tells you which interface is participating in which VLAN. So when I say show VLAN brief, you can see all of my interfaces are participating in VLAN number 1, which is the default VLAN. Guys, always remember, default VLAN is something that you cannot change or modify. Okay, it is not manageable. You cannot make any sort of change in default VLAN. You cannot delete it. You cannot rename it. Clear? Then there are some reserved VLANs 1002, 1003, 4, 5. These were reserved for these technologies, but now we do not use them any longer. But yeah, still they are reserved in the operating systems, so we cannot use these VLANs basically. Now what I am going to do is I will create a VLAN for sales team called VLAN number 10. Similarly, for the HR team also, I'll create a VLAN number 20. And for the tech team, I'll create VLAN number 30. I'll go to my switch. Let's see how do we create these VLANs. For creating VLAN, I'll get into the configuration mode and I'll type down VLAN number 10, name sales. Then VLAN number 20, name HR. VLAN number 30, name tech team and exit. After that, if I check show VLAN brief, you can see in my list, there are 3 new VLANs which are added, VLAN number 10, 20 and 30. And the name of these VLANs are sales, HR, tech team. Clear, guys? Now, what I have to do is I have to put the connecting interfaces into the appropriate VLAN. You see my PC0 is connected to which interface of switch? FA01. Similarly, PC1 is connected to FA02, right? And when I look at switch FA01, FA02, they both are participating in which VLAN? VLAN 1, default VLAN. I want to move these two interfaces into VLAN number 10, which is for the sales team, correct? How do we do that? Let's see. I'll select both the interfaces using the command interface range FA0/0/1 to 2. Then I will set these interfaces as access ports. Switch port mode access. Access ports are those ports which participate in one VLAN. Okay. So we make FA01, FA02 as access ports, and then I'll say switch port access VLAN 10 to make them a member of VLAN number 10. That's how simple it is. Exit. Similarly, FA03 and FA04, these two are connecting to VLAN 20. So I will select this range, interface range FA03 to 4. I will say switch port mode access and then switch port access VLAN 20. Exit. Similarly, interface range FA0/5 to 6. Switch port mode access, switch port access VLAN 30. After writing these commands, I will again check my VLAN database by using the command to show VLAN brief. When I do so, I can see my interfaces are now moved from the default VLAN to the appropriate VLAN. You can see FA01 and 2 is in sales, 3 and 4 is in HR, and 5 and 6 are in tech team. Now, the broadcast domain is divided in 3 parts, and one broadcast domain contains these 2 devices, one contains these 2, and the third one contains these 2. I will only be able to communicate with the device of my broadcast domain. That means PC0 can only communicate to PC1. So let's try ping 210.1.2, and we can see we are getting the replies. But can I ping a device from different broadcast domain? Let's see. I will ping 210.1.3, which is my PC2. Earlier, I was able to get my replies, but now it tells me request timed out. That means the VLAN is not letting me communicate with devices of other broadcast domain. So the implementation is done successfully. Similarly, if I try to ping, let's say 210.1.4, I will not get any reply. If I try to ping 210.1.5, which is PC4, again, a part of different VLAN, still I'll not get any replies. Clear, guys? That's how simply the VLANs can be created. I'm sharing the lab guide for you all to test the same configuration, and then we shall move ahead and discuss about something very amazing called trunking. Parvez, we will discuss about that in a few minutes. As of now, try what we have spoken about. Yes, Pooja, use the first switch. Raghavendra, the actual good habit or the networking practice is to keep network different for different VLANs. That's the right practice to follow. But right now, we want to learn the concept, right? We want to see how, even after being in the same layer 3 network, the VLANs restrict the communication, right? That's basically the idea we wanted to get. That's why we have kept them all in the same network. And I will also suggest you guys to do the same. So test the communication getting restricted after implementing the VLAN configs by putting the PCs in the same network and letting them communicate first. But after configuring VLAN, that communication would be restricted. So try that like this only. Then we will speak about how in different networks we operate. Okay, when you hit some wrong command, it does translate it and tries to figure out that what do you actually mean by sending the command to the DNS. Although we don't have a DNS here, but it will try to send to the global one, right? For example, if I type down something random, it says trying to translate QW, right? How to break this? One shortcut which we find in actual world is Control plus Shift plus 6. We'll try the same here, but that doesn't work in this case. So in Packet Tracer, what you can do is you can skip the time here. This button is to fast forward the time. If you skip it by pressing this button or clicking this button a good number of times, let's say 2, 3 times, then you will see that it skips that time of waiting and gives you the ability of typing down again. So you can use this button to skip and fast forward the time. You see this skip button here? This is used for fast forwarding the time. So you can click this button to fast forward the waiting time. And if you, yeah, Saurabh has mentioned the command. If you type down this command, it will stop trying to translate any wrong keyword that you enter. To ping the devices from switches, we will need IP on switch, which we are going to discuss later with inter-VLAN routing. So wait for that, Saurabh. All right, let's move ahead. I am hoping that everyone must have completed this by now. Now what I will do is I'll move these a little to the left side and I will create another set of devices. I'll take one more switch. Assume that this switch is placed on floor number 1 and this is now being placed on floor number 2. On floor number 2 also I have some members of sales team, I have some member of HR team, and I have some member of tech team. I will connect them all with my switch. And we will configure the same network on these devices as well. So 210.1.0 is something that I'm going to use for the whole topology. So I will go to PC6 IP configuration and I'll set the IP as 210.1.7. Then on the next PC desktop IP, I'll set the IP as 210.1.8. Desktop IP 210.1.9. Desktop IP 210.1.10. PC10 210.1.11 and finally 210.1.12. Clear, guys? Now, just like we have some VLANs on the left side, I will also create same VLANs here on the right side also. So I'll create the VLAN 10 for the sales team, the VLAN 20 for the HR team, and VLAN 30 for the tech team. Let's go to the switch CLI and create these three VLANs. Enable config T VLAN 10, name sales, VLAN 20, name HR, VLAN 30, name tech team. Exit. Then I need my interfaces also to be a member of correct VLAN. So FA01 and FA02 will be a part of VLAN 10, as we can see here. FA03 and FA04 will be a part of VLAN 20. FA05 and FA06 will be a part of VLAN 30. So interface range FA0/122, switch port access, switch port mode access, and switch port access VLAN 10. Exit. Interface range FA0/324, switch port mode access, switch port access VLAN 20. Exit. Interface range FA0/526, switch port mode access, switch port access VLAN 30, and exit. Now, as you might be able to guess already, from PC6, if I try to ping PC7, which is 210.1.8, I will get my replies. But if I ping PC8, 9, 10, 11, obviously I'll not get my replies because they are part of different VLANs, correct? But I have a question for you all. What do you think if I connect my switch 1 with switch 2 and try to make PC0 communicate with PC6 and 7, will I get a reply? Okay, most of you are saying yes, let's try it. let's wait for the connection to come up. We can see the connectivity is up. I'll go to PC0 and I will try to ping PC6, which is configured with the IP 210.1.7. And we can see we are not getting replies, right? So even if PC6 and PC7 are part of same VLAN, still my PC0 cannot communicate with it. Why so? Because the connecting interface, guys, be very attentive right now. The connecting interface FA0/7 is still a member of VLAN number 1, default VLAN. So if it is a member of default VLAN, how will it be able to take traffic of VLAN 10? It is in different VLAN, right? So does that mean if I put FA0/7 into VLAN 10 on both the switches, then can I expect this communication to happen? What do you think? Yes, perfect. But there will still be a problem. VLAN 10 to VLAN 10 communication will happen. But what about VLAN 20 to VLAN 20? What about VLAN 30 to VLAN 30? That communication will still not happen, right? So what we do in such a scenario, we configure the interface as a trunk port. We will configure this link as trunk link. Now what will happen after we configure it as a trunk link? Trunk interfaces are able to communicate with all of the VLANs. Okay. Like I told you, there is access mode. Access mode can only participate in one VLAN. Trunk port do not participate in any of the VLAN, but can talk to all the VLANs. Okay, so I'll write down the definitions here. Access port is part of one VLAN and can communicate to only one VLAN, whereas trunk port is part of none VLAN, no VLAN basically, but can communicate to all VLANs. So if I make this connecting link as trunk, I will be able to take the traffic of VLAN 10, VLAN 20 and VLAN 30 on the other sides. Clear, guys? So let's see how do we configure FA07 as trunk port. Very basic and simple command. You will go to your switch, config T, interface FA0/7. And just like earlier, we were setting the mode as access. Now we will set the mode as trunk. We say that by saying switch port mode trunk. And that's all. Exit. After that, I'll go to the switch 2 also. Interface FA0/7. Switch port mode trunk. We will wait for the interface to come up. Once the interface is up, I will try to ping the PC6 again from PC0. And this time you can see I am getting my replies. If I try to ping PC7, which is on the IP 210.1.8, I am getting my replies. But what do you think? From PC0, if I try to ping PC8, will I get a reply? Yes or no? Perfect. That's going to be a no. Why? Because it's a part of different VLAN. So do this lab and then we will discuss how does my switch figure out if the packet is from a particular VLAN, from the same VLAN or not, right? We'll discuss about what tagging mechanisms are used for it. But meanwhile, you guys quickly complete this lab. Exactly, Sayed. That's what we will discuss after you guys are done with the lab. It works with the help of a tagging, and I'll teach you guys about it. Just do the lab first. I'll open the command which is used for configuring trunk port, interface FA07, and then simply switch port mode trunk. That's the command. No, guys, now trunk will be able to let VLAN 10 communicate to VLAN 10, VLAN 20 to 20, and 30 to 30. For example, from PC2, I try to ping PC8, which is also a part of VLAN 20. I'll get my replies. So ping 210.1.9. You can see I get my replies. So 10 to 10, 20 to 20, and 30 to 30 communication is established with the help of trunk link. All right, I can see many of you are done. So we will move to inter-VLAN routing. We'll discuss about how inter-VLAN routing works. But before that, we need to understand what exactly happens between the devices, which makes me realize if the packet belongs to VLAN 10 or VLAN 20, right? So uh, before going on mute, I told you guys there is a tagging mechanism. Let's understand what is this tagging mechanism. My screen must be visible now. So we just discussed one scenario where there is switch number 1 connected to VLAN number 10, connected to VLAN number 20, connected to VLAN number 30. Then we have a switch 2 also connected to VLAN number 10, VLAN number 20, and VLAN number 30. When I send traffic from VLAN 10 to VLAN 10, it gets delivered, right? But when I send traffic from VLAN 10 to VLAN 20, it doesn't gets delivered or doesn't brings me a reply, right? How does these switch find out what VLAN a packet belongs to? They find out using tags. We can say after I have configured this link as trunk link, this will be taking the VLAN 10 traffic, this will be taking VLAN 20 traffic, and will also be taking VLAN 30 traffic. So how do I differentiate between all three of them? I do differentiation with the help of VLAN tags. Make sense? Now, this encapsulation or this tag is added using a protocol called IEEE 802.1q. Clear, guys? So IEEE 802.1q is the protocol that lets me put a tag on my frame, which will tell the other switch if the VLAN is the same VLAN or a different VLAN. So for example, when a packet will be generated from a PC, which is a part of VLAN 10, it will reach my switch, and before switch sending it on trunk link, it will put a tag on it that will specify that this packet belongs to VLAN 10. Now the packet will travel to switch 2. Switch 2 will find if the destination of that traffic is in VLAN 10 or not. If it is in VLAN number 10, then it forwards the packet to the destination, or otherwise it simply discards that packet. If the destination is not in the same VLAN, it is going to discard that packet. Make sense? This is how the VLAN to VLAN communication is processed between switches which are configured with trunk link. Now, the next thing that we are going to speak about is inter-VLAN routing. Okay. Okay, imagine you are in a factory. In this factory, there are different sections. There is a section for raw material. There is a section for production. And there is a section for packaging. So guys, in order to sell my product from this factory, I have to take raw material from here and I have to send it for productions, right? From there, I have to take the product and send it for packaging. Then from there, I can send it out for selling it, right? But we do not say that in the factory, all of the things will be managed in the same section. We don't do it like that, right? We can't say that in the same room, production will happen, in the same room, packaging will happen, and in the same room, raw material will be there, right? So what we do is we categorize them into different sections, but we do make them communicate with each other. Same is the case for inter-VLAN communication. There are scenarios where I might want to put them into different sections like sales team, HR team, or tech team. But there is a possibility that I might want a communication between sales and HR, sales and tech, and vice versa. So this communication is enabled using inter-VLAN routing. Clear, guys? Now, inter-VLAN routing can only be enabled with the help of a layer 3 device because now we will have to deal with different networks. So when we implement VLANs, the appropriate method is to put the devices or to use different subnets for all the different VLANs. So for example, if my switch 1 is connected to sales team, for sales team, I'll be using a subnet, let's say 192.168.1.0. Then for my HR team, I might be using 192.168.2.0. So the appropriate approach of configuring VLAN is by putting them into different subnets. In our previous example, we kept them all in the same subnet just for the sake of our understanding. Okay. But the right method is like this, where you use different VLANs and different subnets. Okay. So switch 1 is connected to sales team with subnet 1.0, HR team with subnet 2.0, and tech team with the subnet 192.168.3.0. Now, in order to make my first network communicate to second and third network, I need my device to have the understanding of layer 3 because that's IP routing which I want to implement here. Do you all agree? Along with this device being layer 3, I need a gateway IP for the sales team. I need a gateway IP for the HR team as well as a gateway for tech team. Correct? So that the sales team, when wants to communicate to HR, they can send the traffic to gateway. Correct? Just like in a factory, when your raw material needs to be sent to the productions, then there will be a manager or a point of contact who this basically who to whom the team of raw material will reach out so that he can guide them to send it to the production, right? Just like that, now when I want my sales traffic to go into HR, I need some gateway for that. Correct? Now to configure this gateway, what we do is we create SVI, which stands for switched virtual interfaces. A switch virtual interface will be used as gateway of sales, HR, and tech team. Now, why are we not using the actual interfaces? Why are we using SVI, which is a virtual interface, Any guesses, guys? So why are we not using the actual interface as our gateway? Let's understand. Because in sales team, if you see, there will not be just one device, right? There can be 10 devices, there can be 20 devices. So I cannot put IP as a gateway on all the 20 interfaces, correct? Yes or no? We cannot put the same IP on all the 20 interfaces, right? So what we do instead is we create a virtual interface, we bind it to the appropriate VLAN, and then we use that as our gateway. So let's see how this configuration is done. I'll share my screen and I'll create a new topology. This time, the switch that I'm going to add will be a layer 3 switch. You see these are called multi-layer switches, which can operate on layer 2 as well as on layer 3. So the third and the fourth and fifth, these are the two switches, which are multi-layer. If you will check the fourth one, it's a normal switch. But if you check the fifth one, you'll see some ports like this. This is a power over Ethernet switch. We cannot use it here in packet tracer, so I'll just delete it. So the one that you have to use is fourth one. Okay. Take the fourth switch and then connect multiple devices with it. This will be my sales team. This will be my HR team. This will be my tech team. So I will connect all of them to my multi-layer switch simply like this. Then like we discussed, this will be sales team. This will be HR team. And this will be my tech team. For the sales team, I will use the VLAN number 10 and the subnet as 210.1.0/24. Similarly, for HR team, I will use the VLAN number as 20 and the subnet that I'm going to use will be 210.2.0. Then for the tech team, I will use the VLAN number as 30 and the subnet as 210.3.0. So very first thing that I'll do is I'll put IP on the end devices. Along with the IP address, I will also be configuring gateway IP address. Okay. So for 210.1.0 network, I'll use gateway as 210.1.1. So the IP here will be 210.1.2. Subnet mask will be /24 and default gateway address will be 210.1.1. Then next PC desktop IP 210.1.3 with a gateway of 210.1.1. Clear, guys? For the devices of HR team, I'll use the subnet 210.2.0. So the IP will be 2.2 and gateway will be 2.1. PC15 desktop IP 210.2.3. 210.2.3, 210.2.1 will be my gateway. For the devices of tech team, we are using the subnet 3.0, 210.3.2, 210.3.1. Desktop IP 210.3.3, 210.3.1. I've configured IP and gateway configs on all of my end devices. Then now it's time to put them into the appropriate VLANs. So I'll go to my switch CLI. I'll say no to the question. Enable configure terminal. VLAN 10 name sales. VLAN 20 name HR. VLAN 30 name tech team. Exit interface range FA0/122 switch port mode access switch port access VLAN 10. Exit interface range FA0/324 switch port mode access switch port access VLAN 20. Exit interface range FA0526 switch port mode access switch port access VLAN 30. Exit. Any questions or doubts so far? Perfect. Now I can explain to you why we are using virtual interfaces. For VLAN 10, I need the gateway 210.1.1. Do I configure it on FA01 or do I configure it on FA02? If I put it on FA01, my PC12 will be able to use it, but not PC13. And if I do it on FA02, then PC13 would be able to use it, not PC12. So to fix this problem, we create virtual interfaces. How do we do that? Let's see. We'll say interface VLAN 10. That's how you create an SVI. And then you put IP address to it. IP address will be 210.1.1/24. No shutdown, exit. That's how simple it is. Then interface VLAN 20. For VLAN 20, the IP address should be 210.2.1/24. No shutdown, exit. Then interface VLAN 30, IP address 210.3.1/24. No shutdown, exit. Clear, guys? After this, I can go to my PC12. I will first try to ping my own VLAN device. So 1.2 is myself only. I'll try to ping 1.3. I can see I am getting the replies. Now, in order to ping 2.2, if I try to ping 2.2, we can see my packets are getting dropped, right? Like if I skip it, you can see all the packets are dropped. Why so? Because on my switch, I will have to manually enable the layer 3 capability. Okay. So by default, my switch will operate on layer 2. In order to make it layer 3 capable, I have to run a command IP routing. Once I enter the command IP routing, then I will try to ping again. And this time I will get my replies. Let's wait for them. First packet dropped and then I started getting my replies. Clear, guys? This has also enabled inter-VLAN routing. I can get my replies from VLAN 20. I will also try to ping the device of VLAN 30. And you can see we are getting the replies. The IP for PC12 is 210.1.2 and it belongs to VLAN 10. But yeah, I am able to communicate with the other VLANs, which means I have successfully implemented inter-VLAN routing using the SPI method. If there is any questions or doubts, do let me know. Otherwise, I'm sharing the lab guide for this one. Try out the same and let me know once you are done. Okay, I did explain why we didn't assign IP to physical interface. Anyone who would like to answer the user M? What do you think? Why are we not putting it on the physical interface? This is not a layer 2 switch, it's a multi-layer switch. It's operating on layer 3. That is why only the inter-VLAN communication is enabled. So it's not a layer 2 switch. Ankush, we will discuss router on a stick later on. Wait for that. Very good. Everyone has explained it very well. So because we have a lot of interfaces, we cannot put gateway IP on all of them. So for that reason, we put it on a virtual interface. Due to less port, we will use SVI, not the number of ports. It's basically, see, if I want to give a gateway IP 210.1.1, what do you think, M? Where do I put it? On FA01 off switch or FA02 off switch? Which interface? We don't have an answer, right? Similarly, if I have, like right now, I just have two interfaces. What if I have 50 interfaces in my VLAN 10? I cannot put IP on all of them, right? I can only configure it for once. So that's why we create a virtual interface which can work with all of the physical interfaces and can manage the traffic of it. Exactly. For inter-VLAN communication, we always need a multi-layer switch because the layer 3 understanding is required. A layer 2 switch can never do inter-VLAN routing. VLAN tagging is a part of VLAN trunking concept. So same topics, they are not different. All right, we have got some questions here. How to untag any VLAN in trunk using native VLAN? What will be the command for that? Ankush, I'll explain a native VLAN. Don't worry about it. Will IP routing work on 2960 switch? So Saurabh, if you see 2960, it's a layer 2 switch. And layer 2 switch cannot work on layer 3. So no. Simple answer, no. Now we have a question about native VLAN. I'm hoping that all of you must have completed this lab by now. So we'll scroll up. We'll come back to the previous topology. Here, if you check your trunk details using the command show interface trunk, it gives you some information on how trunk interface is working. First of all, it tells you it is FA0/7, which is the trunk port. Then trunk can be configured statically, which is the method we have used, and can be used dynamically. So this on method tells you that it is using the static method. On means static. Okay. Encapsulation, which is being done, is using 802.1q. The status of the link is trunking. Native VLAN is one. Now the question is, what is this native VLAN and how is it used? Does anyone have any idea on it before I start speaking about it? Many of you are saying is it is the default VLAN. Yes, that's correct. Default VLAN is also VLAN number one and native VLAN is also VLAN number one. But the meaning of native VLAN is a little different. A native VLAN is that VLAN that carries untagged traffic on a trunk port. Meaning, if a traffic is generated from VLAN number one, we can say it will travel on the trunk link without any tags. Clear? Whenever my switch will receive a traffic on which there is no tag, it will be assumed that it belongs to native VLAN. That's why it's pretty important that we keep the native VLAN same on both the sides. As you can see, it is one here and one here. So the reason is because the native VLAN is going to carry the untagged traffic, and whenever my switch 2 will receive any untagged traffic on the trunk link, it will automatically understand that it belongs to native VLAN. Now the question is, why do we use it, right? On a trunk link, all of the traffic which is generated by these end devices, which are in some VLAN, will have a tag on it, right? But there are some protocols, some legacy devices which want the traffic without any VLAN tags, which we are going to explore later on. So to handle the native, we can say to handle those protocols and to make sure that the VLAN having most of the devices doesn't has to put any tag on the traffic. What we do is we configure a particular VLAN as native VLAN. Make sense? The question is, can we change it? Can I change my native VLAN from VLAN 1 to VLAN 10, let's say? Yes, I can do that. The configuration is very simple. You have to get onto the trunk interface FA0/7, and there you will say switch port, trunk, native VLAN 10. Let's say I change the native VLAN on switch 1, but I don't do it on switch 2. So let's see what happens. Here it is 10, but on switch 2, it is still 1. You see, it started creating logs that tells you that there is a native VLAN mismatch. On the other side, we have the native VLAN as 10, but on our end, it is 1. So it's an error that needs to be fixed by changing the native VLAN on switch 2 also as VLAN number 10. Once I do so, my port will be restored and the connectivity will come up again. That's how the concept of native VLAN works. Is that clear to all of us? No, Parvez, in our case, there is no device in VLAN number 1. That's why it was not connected to any device. But right now, as I have changed my VLAN 10 as native VLAN for these two switches, so I can say all of the traffic that belongs to VLAN 10 will travel over the trunk link without any tags. No, Parvez, it will not get discarded. It will be forwarded to VLAN 10 only because it belongs to VLAN 10, and as the native VLAN on both the switches is VLAN number 10. So any untagged traffic which my switch 2 receives, let's say from switch 1, it will be automatically understood that it must belong to VLAN number 10, as that is my native VLAN. I hope that answers your questions. And that brings us to the end of this discussion. Tomorrow, we will explore another way of inter-VLAN routing and we'll try out some interesting labs. So that was all for today. Thank you so much. I hope you enjoyed the class. I'll share the notes in the group. Take care. Bye-bye. Do practice what we have discussed. Oh, I'm so sorry. I said tomorrow. We don't have a class tomorrow. Sorry, guys. We'll have it now on Monday. So my bad. We'll have class on Monday. Let me put that in group as well on Monday now. If native VLAN is different on both the sides, link will work anyways, right? No, it will not work. No, Nicholas will keep getting errors. It will not let us operate if the native VLAN is different. Thank you guys. You too have a nice weekend. Enjoy your day. Bye bye. Take care. See you on Monday.